The last default routes type that I want to discuss in the terms of RIP version 2 is going to be the idea of a reliable conditional default route. Now, when it comes to reliability, we have tools that we have available to us, and none of them are going to be more useful than IP SLAs, IP service level agreements. Now, what we're going to do is I'm going to create a few steps here. So the first step is that one, I'm going to create an IP SLA, and that IP SLA is going to actually see if I can reach the IP address 172.16.20.20. Now, if that is reachable, what I want to do is I want to create a static route. So this in its own right is conditional. So I want to monitor this prefix. Let's take a look and see exactly what goes into that. So on R1, what I want to do is I want to say config T, and I'm going to say IP SLA 1. And what I'm going to do is I'm going to say ICMP echo, and I want to ping 172.16.20.20 exactly. And I'm even going to say I want to source it. See, source interface LO0. All right. Now, what I want to do is, let's say I'm going to specify some values here. So I'm going to say my timeout is going to be 1,000 milliseconds. But the problem is that's actually less than my threshold of 5,000. So what I'm going to do is I'm going to set up my threshold here, and I'm going to say my threshold is going to be 1,000. Then my timeout will be 1,000. I think they can match. And then my frequency is going to be every second. So now that I've done this, what I've got is I have an IP SLA session. Do show IP SLA statistics 1. Now, it tells me my status is unknown because I haven't activated it yet. So I need to turn it on. So what I'm going to say is IP SLA schedule 1 with a start time of now and a lifetime of forever. So now that that's actually running, let's see if I haven't, I could have screwed up my settings and tried to make it happen so fast that it's never going to detect a successful reply. So let's check that. Do show IP SLA statistics 1. All right, we have 20 successes. So that's telling me that the system is able to reach that IP address. This is a reliability check because it's actually verifying reachability. So I'm doing it via a ping. So I'm sending an ICMP echo out to that IP address, and I'm expecting to get a reply back. If my reply comes back, I have a return code on the operation of OK. And notice I have no failures. Let me repeat the show command. We've got 45 successes and we have no failures, and it's going to ping every second. So we should be able to track this and monitor it. And the question is how do we do that? Well, what I want to do is I want to set up a process here called track. Now what I'm going to do is I want to track and give it a number. I'm going to just say 1. It doesn't have to match the IP SLA setting, but I do want to say track object 1, and that object is going to be let's see, IP SLA, and I want to use IP SLA 1. So now we've got 2 conditions. So first of all, do show IP SLA statistics 1 is returning a number of failures of 0 and a return code of OK. Now, as long as it's returning a return code of OK, my tracked object show track 1 is going to come back, do show track 1, is going to come back and say that it is up because I'm monitoring and tracking the state of my IP SLA. Now what I want to do is this. Based on this, now what I want to do is generate an actual static route. So what I'm going to do is I'm going to create a static route here that's going to say IP route, and the static route that I'm going to create is going to be 101, 101, 101, 101, 255, 255, 2550. Actually, we'll use 0. So that's the network and the mask. And what I'm going to say is I'm going to send this to null 0, but I want to do it only if my track 1 object is alive. So if my track 1 is returning a code of up, then I want to generate this prefix. Let's watch what happens. So show IP route. Notice now, well, let's see, IP route static. Notice now I have a static prefix going to null 0. Now if I go over to R20 and shut down the interface for 172.16.20.0/24, and then I return over to R1, this prefix should be removed. So now it's not in my table. But how does that help me with regard to generating my default prefix, my default route? Well, now all we do is we've got the reliability component that's taking place because of the IPSLA. Now all I want to do is be able to, again, create a route map that's going to monitor and use an IP prefix list that's going to monitor that static route that we're creating. So first of all, what we'll do is let's go over to R20 and bring that interface back up. No shut. Now when I go over back to R1 and I re-execute this, it should return to my table. So show run pipe include. Oh, there it is. Track state went to up. Now it'll be in my table. There it is. Now what I want to do now is I'm going to use an access list, I'm sorry, not an access list, an IP prefix list to track this particular network. So again, let's do this. Config T. So what I'm going to do is I'm going to say IP prefix list sequence number 10 permit, not permit, what am I doing? Give it a name. And let's say, we'll say bogus route permit. And what am I doing? Sequence number permit. It's after the sequence number. Sorry. Permit. And then I need to track that prefix. And I said it was going to be 101, 101, 101.0/24. Pardon me on the syntax. Bogus dash route. Sequence 10. Permit 101, 101, 101.0/24. /24. Do show IP prefix list bogus underscore route. And there it is. So it's showing up in my table now. So what I'm doing is I'm using the IP prefix list to look for that dummy prefix that we had. So now what I want to do is I need to create a route map. I'm going to say route map. And I'm going to say track bogus underscore route permit 10. And I'm going to say match IP address prefix list, and the prefix that I want to track is going to be bogus route. Enter, exit. Then we go to router rip, and then what I do is just simply do default dash information originate route map, and it was track bogus route. Do show route dash map. Track bogus route. Right there it is. So hopefully I got everything correct. So now based on that prefix appearing on my routing in my routing table, am I generating a default route? Show IP route static. Actually, it won't be static. There it is. A default prefix. We can even scroll up and see gateway of last resort is set. Now what I want to do is I want to go over to R20 and bring that interface down. Shut. Go back over to R1. Notice my track state went to down. The moment my track state went to down, what will happen is I should no longer have that show IP route static in my table, which means if I go over to R2, I am going to find that I'm no longer generating the default route. So again, we'll just simply scroll up. And there we go. So if I look at it from the point of view of R22, show IP route. Gateway of last resort is not set. If I return over here 220 and say no shut, then return to R22, what will end up happening is the system will ultimately advertise it. Let's wait a little while. And see what happens. It's going to take time because it takes a little bit of time for R1 to determine the link is back up. It just did. Show IP route static. The prefix should now be in my routing table, which it is. Now that it's in my routing table, if I go over to R22, I should see that I now am advertising it from R1. So as we see, this gives us the idea of the fact that we can have not just default routes, we can have conditional default routes, and we can even have conditional default routes in the context of using reliability, whereby in order to make it work, what we do is we create a static prefix based on the availability of an OK status with an OK return code coming from an IPSLA session. And then what we do is we use our IP prefix list and our route map to monitor that bogus or that generated prefix that we're inserting into the routing table, and then based on its presence, that's determining on how we are going to be doing this idea of a reliable default route. So with that done, that wraps up all of our conversation about default prefixes. All I want to do is just hit some miscellaneous stuff in the context of RIP version 2 for IPv4, and we'll move into the idea of RIP for IPv6. I'll see you guys in the next video. Bye-bye.